So I'm going to just talk about how camera-trap data, bycatch from camera-trap surveys can be utilised for other species that you don't necessarily plan for when you design surveys, assuming that the survey design itself is robust enough. So back in 2010, just to give us a little bit of perspective, the Secretariat on the Convention of Biological Diversity said that the greatest drivers of global biodiversity loss, unsustainable management of forests and habitat loss through land conversions for agricultural purposes. Forest here in South Africa is our smallest biome. Indigenous forest covers about 0.6% of the country's land surface, but it actually contains about 14% of South Africa's birds and mammals. So clearly there's a disproportionately large representation of biodiversity in such a small land area. So in such a threatened biome, we're seeing significant threats and changes to the landscape. And natural landscape transformation results in significant changes in biodiversity. It's because anthropogenic fragmentation of forested landscapes is not a random process, it's commercially driven for things such as agriculture, forestry, and urbanisation. And through this fragmentation effect, this progressive dividing of contiguous forest tracts into increasingly smaller and more isolated habitat patches, we see changes in the diversity and abundance of niches and resources. And as these change, we see changes in species richness and abundance of these species that are dependent on these niches and resources. And in particular, we tend to see a decline in specialists because they are dependent on specialised niches, which tend to be the first to go during this fragmentation effect. So as patches become increasingly isolated, we see decreasing connectivity of habitat patches, which has implications for healthy gene flow. And an increase in what we call edge habitat. So if a forest was once contiguous and it has internal forest structures associated with it, and a road or some kind of barrier goes through, this internal forest structure changes to edge structures, changing the niches, resources, and essentially the habitat structure therein. And this also allows for an increase in alien invasive flora and fauna to come into areas of forest where they normally would have had challenges getting in the first place. So, obviously being such a restricted biome and containing a large amount of species, and particularly some specialists, we're likely to see some species of conservation concern. So I'm going to focus on the spotted ground thrush, which is a globally endangered forest specialist. It's got a disjunct distribution across Africa. We've got 5 subspecies, but I'm going to focus on the southern African subspecies, Zuthera guttata guttata, which we have on the east coast of South Africa, between the Eastern Cape up to the Mozambique border and almost certainly beyond into the Mozambique-Maputoland forests. So BirdLife South Africa, BirdLife International wish to develop a species action plan including baseline, distribution, mapping and monitoring of the species. And because it is elusive, it's very skulking, and we can attest to this during 285 point count surveys that we conducted during the wintering season. We only detected it 5 times. I think Robin was saying earlier during non-breeding periods when birds aren't advertising themselves, they are actually very difficult to detect if they are skulking and elusive in nature themselves. So although this is actually bycatch data, it's clearly a perfect candidate for camera-trap surveys. So we have the northern population, which breeds in the inland forests of Zululand, and the southern population, which breeds in the coastal forests of the Eastern Cape up to southern KZN. And during the non-breeding season, March to September, the northern population makes a littoral migration eastwards towards the coast, and the southern population makes a latitudinal migration northwards. So basically, pretty much the entire population of South Africa's spotted ground thrush is contained in the coastal forests of KZN during winter. But the Indian Ocean coastal belt forest is not without its problems. We've estimated, or Peter Olivier and colleagues have estimated, that we've actually lost about 82% of the indigenous forest that once was present on the east coast. And we have 2 vegetation types. We have our indigenous forest, which is critically endangered. It's highly restricted, but large parts of it are within the protected area network. And then we have coastal thicket dense bush, which is highly abundant, but largely unprotected. And if you can come to the forest coastal conservation session on Thursday, you'll see we'll talk a little bit more about how coastal thicket dense bushes, most likely actually regenerating indigenous forest. But these are our two broad vegetation types, and then we have our habitat subclasses of scarp forest and coastal forest itself, and then we have a range of land use types, so our nature reserves, patches that are contained still on farms, within sort of eco-estates, these impenetrable places people like to live and be within nature, and patches that are retained within the urban land use mosaic. So our survey regime was between June 2014 and May 2016, and very similar to what we've already seen, we had the Moultrie cameras 20 to 30 centimetres off the ground, deployed over 21 survey days, firing for 24 hours with a passive infrared trigger and a 30-second delay between pictures. And we put them in as many different scarp, coastal and dense bush patches as we could geographically access across the widest range of our land use types, nature reserves, the residential areas, farms and the eco-estates. And of course, because the ground thrush is only present in our region during the winter, we analysed purely the winter season from 2 years. So our main objectives were to establish habitat patch occupancy for spotted ground thrush in southern KZN and examine the habitat requirements and response to fragmentation effects and the surrounding land use mosaic, so in line with what BirdLife were hoping for in their action plan. So similar story, we had a 400 metre by 400 metre grid overlaid over all of our habitat patches that we identified in GIS, and we placed a 1 kilometre buffer around each camera and quantified the land use therein. And then in the field itself, we conducted microhabitat surveys within a 20 metre fixed radius around each camera-trap point. We measured each patch in terms of actual patch size, so its hectarage, and its isolation distance. We defined the isolation distance as its distance from a mainland patch, which we quantified for numerous reasons, one of the reasons being at 90 hectares, one of the reasons being it's simply the largest patches that we have of mainland coastal forest in our region, and also for other reasons such as spotted ground thrush breeds mainly in 100 hectare and greater patches, and also the majority of the entire functional community of birds is contained in patches 90 hectares or larger, but that's another paper for another day. So the environmental covariates that we wound up with, at the landscape scale, we have forest patch size, our mainland isolation distance, whether the patch was in forest and dense bush, proximity of woodland and open bush, of cultivated land, proximity of urban mosaic, and whether the camera trap was in an urban area, and proximity to water. And then at the microhabitat scale, we had our foliage height diversity index, our Shannon-Wiener index, and percentage of bare ground, leaf litter, short grass cover, tall grass cover, short herbaceous cover, and then the stem density of trees at 2 to 5, 6 to 10, 11 to 15 metres. So we used all of these covariates into our modelling regime within programme presence, same as we've seen already, to determine the site occupancy, the probability that a site is occupied, and the detection probability, the probability of detecting the species given that this species is present at the site within a single season occupancy model. So each sampling occasion was treated as a temporal repeat of the survey, and we're looking for a presence-absence within the presence-absence matrix, a naive occupancy of greater than 2 to allow for robust statistical inferencing. And we treated within our Keiki information criterion, as you've heard, anything with a delta AIC of less than 2 was treated as sort of having equivalent explanatory power for our model fit. So first of all, we had reasonable success, but as you can see, it's a pretty cryptic bird. So we had success in that we captured it far more frequently than we did during the point count surveys, but actually at the site level, the naive occupancy rate was actually too low to do anything statistically with. We had 42 out of 275 camera sites which detected the bird. So what we did was we pooled every camera trap that was within a patch to give us a patch occupancy. And there, lo and behold, we had 23 out of 82 patches that were occupied, which gave us a naive occupancy of 0.28. Happy days for statistical inferencing. So we had our top model that came out with the highest model fit, the most robust, giving us an overall occupancy of 0.39 with a detection probability of 0.11. And our main explanatory covariates at the occupancy side were landscape. It was patch size and it was the isolation distance. And then our main explanatory covariates on detection probability was actually at the microhabitat scale, percentage of short herbaceous cover and percentage of bare ground, which on the face of it sounds counterintuitive for a terrestrial foraging bird. But our top model told us that patch size and isolation, bare ground, stem density of 6 to 10 trees, and a Shannon-Wiener index was important on the occupancy side, and bare ground, short herbaceous cover, short grass cover, cultivated land, stem density of 11 to 15 trees was important on the detection probability, side. So what this means when we break it down is that patch size, percentage bare ground, and patches of forest within the urban land use mosaic actually affected occupancy positively, whereas percentage of short herbaceous cover and stem density of 11 to 15 metre trees affected detection probability positively. Then on the negative side, increasing isolation distance, stem density of shorter trees, 6 to 10, dense bush, and a high heterogeneity index affected occupancy negatively. And percentage of bare ground, percentage of short grass cover, and percentage of cultivated land influenced detection probability negatively. So to put this into trends, first of all, our low capture rate confirms rarity of this species in the only place where it exists in the country. And overall, it has a preference for tall trees with an open understory, which implies a dependence on indigenous forest. And it has a preference for a restricted indigenous forest over the abundant dense bush, confirms this range restriction. And we also see that it's avoiding small isolated patches in proximity to agriculture. So this is implying that actually this species is negatively affected by the fragmentation effect. And of course, the success of the study supports the use of camera traps for surveying elusive terrestrial forest birds. So in terms of conservation implications, this is further evidence for the negative impacts of fragmentation on forest specialists. And there are negative predictions for its persistence, because the continued anthropogenically driven landscape modification is obviously going to exacerbate these trends that we see. And also this increase in the edge effects is increasing the ability of invasive species, particularly domestic cats, to get into centre of forests where they never were able to before. And it's estimated that in fact 50% of spotted ground thrush clutch failures is a result of nest predation, particularly from cats and things like wormslang as well, which of course are in forests anyway. So going forward, we need to identify key sites for conservation management, particularly in the Eastern Cape of South Africa. We believe that we've got some key sites now in southern KZN. And the main take-home message here is to never underestimate the value of camera trap bycatch. And to just bring this message home, in 2014 we surveyed this beautiful patch of riverine, what would be classed as coastal dense bush, but it's approaching forest really. Somewhere, I won't say where, on a farm in southern KZN. And we captured spotted ground thrush on the cameras, and we also captured them and ringed them. We recaught them a couple of weeks later, and we also had them on the camera traps a few weeks later. So this implied that this was actually wintering range habitat as opposed to they're just on passage. We tried to resurvey there the following year, and for several reasons we were denied access. So we went on Google Earth, and we discovered that this entire patch had been removed. And a casual drive up the R61 or the N2 will show you that the landscape is changing rapidly. These dense bush patches, every time you drive up and down, you notice another patch has disappeared. So this is happening constantly, rapidly, and we need to work on a solution. And hopefully, again, if you come on Thursday, we're working on a solution for protecting some of these coastal dense bush areas, which allow not only species to migrate and disperse throughout the fragmented area, but also they're refugia for all these specialised traits that otherwise are going to disappear. Sorry, that's a depressing note to end on, but this is conservation after all. Many thanks.